Hi, I want to give you a few examples of our difference quotient as a limit as h approaches 0. What you're going to see on a quiz for 2.1, 2.3 is problems like this, and I'll give you different functions to work with. You're only going to see one on the quiz, maybe two. If it's 2025, it's just going to be one. I'm just hoping to make this video future-proof. So maybe in the future, after 2025, I'll put a couple questions on the quiz. But let's look at a few examples. If f of x equals x squared plus 1, what I could do is I would have x plus h squared plus 1 minus x squared plus 1 over h, and I want that limit as h approaches 0. So what we do there is we simplify. And I can start canceling things out. My x squareds are gone, my 1's gone, cancel out an h. And what I end up with is the limit as h approaches 0 of 2x plus h. And if I plug in a 0 for h, I just get 2x. Now the reason why we're doing this is because eventually this is how we're going to find our derivatives. We're doing derivatives light, or like the long way. Let's try another example. What if I've got f of x equals x cubed? This was one of our homework problems. What I would have is f of x plus h minus f of x over h. This would be x plus h cubed minus x cubed over h, which would be, I gotta do this, I gotta work it out real quick, sorry. X plus h, x squared plus 2xh plus h squared. This would be x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed. This is going to get me x cubed plus 3x squared h. Actually, let me do this. This is going to be x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed. That's from here over h. Now we start canceling out. X cubes, h, and I end up with, really it's the limit as h approaches 0 of 3x squared plus 3xh plus h squared. And if I plug in a 0 for h, this is gone, and I end up with just my 3x squared. Because these two terms, 0 times anything is 0, so it ends up being plus 0 plus 0. My final answer would be a 3x squared. I'm going to give